Welcome viewers and subscribers. Welcome back to my channel. Welcome back to another video. So in today's video, I am going to present to you a Bebo Arch Bridge. So if you have watched my video on the steel corrugated arch bridge on the Melrose bypass, I did mention to you that I'm going to do a presentation on a Bebo Arch Bridge. So therefore, this Bebo Arch Bridge is located somewhere in the region or somewhere in the range of about 8 to 10 miles from where I'm living in Norristown, Pennsylvania, United States. So I have worked on this bridge as a construction engineer slash construction inspector. So I'm going to present this bridge to you, the different components that make up the bridge, and also the construction process that were undertaken in constructing this bridge. So I want you to watch the video until the end. And before I finish this introduction, I want to say a special thanks to those of you who have been subscribing to the channel, who have been watching my videos, and who have been interacting with me through your comments. Enough respect for that, and especially if you have watched the videos until the end. So stay tuned for this video, and if you like the video as well, let me know in the comment section, and please ask me questions if you do not understand, because when you ask me questions about the presentation of the bridge, it reinforces what I have known already. And also, if you ask me a question that I do not know, it gives me the opportunity to research the question and therefore educate you as well as educate me as well. So watch the video until the end and stay tuned for the video. Thank you.
Welcome viewers and subscribers. Welcome back to my channel. Welcome back to another video. So I did a intro for this video, and I did say to you that I'm going to present to you what a Bebo Arch Bridge is like. So what you're looking at, folks, is a Bebo Arch Bridge. So a little background knowledge about this bridge is that I have worked on this bridge personally from January until June of 2016, but the bridge actually starts in 2015 of June. So the length of construction was approximately 1 year. So this bridge spans what is known as a bicycle trail, and on top of the bridge is a pavement structure consisting of 2 lanes, one going east and the other going west. So what you're looking at now, immediately in front of us, is wing wall 1, and on the opposite side is wing wall 2, and across from wing wall 1 is wing wall 3, and across from wing wall 2 is wing wall 4. So there are 4 U-wing walls that is on this Bebo Arch Bridge. So what you're actually looking at now, that arch concrete structure, is known as a precast Bebo Arch, and above the Bebo Arch is what is known as the spandrel. So both the spandrel and the Bebo Arch was precast from the company and shipped to the construction site. So the Bebo arches and the spandrels, they were manufactured at a precast company and shipped to the construction site. So let me show you what the spandrels are. So immediately above the Bebo Arch, that's the spandrel. And what that colored looking fabric that you're looking on, it is known as architectural treatment. So we just put the architectural treatment on the bridge just to boost the aesthetical look of the bridge. And the fact that it is in an historic area, we are mandated to do such. So let me take you to beneath the bridge and show you more of what is going on. So what you're looking at now actually is the Bebo Arches. So it spans from one end all the way over to the opposite end. So those holes that you see in the Bebo Arch here, as I mentioned to you before, and if you have been following my video, those are the weep holes. And you know what the purposes of the weep hole are. It is to release the hydrostatic pressure that is built up behind the wall. And you can see now that these walls, these weep holes, they are working. So that tells us that there are some amount of water that is backed up behind this bridge when we have heavy rainfall. So we can see this green algae here that is at the edge, the bottom edge of the weep hole. It is also present here. And in this one here, we have what is known as this white substance here. It is known as efflorescence. So efflorescence is basically the calcium that is coming out of the concrete structure when the structure is exposed to moisture or water. So we have efflorescence here present again, and we can see that some of the backfill material here that is in the weep hole. I'm going up. Right, so you see, so these weep holes here need to be unclogged for the free flowing of water to come through. So there are 7 segments of this Bebo Arch here. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 segments, right? And let me give you an explanation of what type of foundation system that we use to anchor these Bebo arches, the 7 segments of Bebo arches. So we didn't use a conventional foundation system for this Bebo Arch Bridge. What we do is we use H-piles, steel H-pile that was driven down, I think, 100 or so feet. I think it was 100 feet below ground surface, and it was driven to bedrock. So those H-piles were driven to bedrock, and the portion of the H-piles that was above the ground level, we place reinforcing bars across them and pour what is called a pile cap. I did have the drawings for these bridges, but for some reason I do not know where I misplaced the drawings. So some of these weep holes, as you can see, they are clogged with aggregates and different type of debris, and that can restrict the water from flowing through these weep holes. So after the pile cap was poured, what we do is anchor the Bebo arches to the pile caps. So the H pile was driven 100 feet below ground level, was driven to bedrock, and the portion of the H piles that was above ground, a pile cap was poured over it, and those pile cap, the arches was anchored to it, that in the arches was bolted to it, and that forms the foundation structure for this Bebo arches. So again, this bridge, as I said to you before, I worked on this bridge back in 2016 as a construction inspector. So what you're looking at now is another single span bridge, and I'm going to give you a little background on that, because simultaneously when we were constructing this bridge, that bridge was being constructed as well. I never worked on this bridge, on that bridge in particular, but I was present here overseeing this bridge, and from time to time I go across and look what was going on. So on the opposite side here is the same thing. So we are looking at, on this side here, wing wall 4, and we are looking at wing wall 3, and the spandrel above the Bebo arch. And that concrete structure that you see there is what is known as the barrier. So I'm going to take you up to the top there and show you what the road pavement is like. So I'm going to give you now what the construction process was like. So the construction process was that after we have put up the Bebo arch and the wing walls, we place structural backfill in between. So the structural backfill, it was compacted at every 8 inches lift. So we go up 8 inches, we compact it, we go up another 8 inches, we compact it until we get to our desired elevation for the concrete slab, the deck, to be constructed on to form the pavement structure for the bridge. So I'm going to take you up now and show you what is going on top of the bridge. But before I do that, I'm just going to give you a small overview of this single span bridge here. So this single span bridge here, even though it's a single span bridge, it is very, very wide. So this bridge carries 6 lanes. So there are 3 lanes going east and there are 3 lanes going west. And what you're looking at now is our fascia beam beneath the trail, and that beam is known as the PA bulb T beams. So we use those PA bulb T beam a lot, along with adjacent box beam and spread box beam. So with the PA bulb T beam, the maintenance is less on them as against using steel beams. So they are precast and they were also shipped to the construction site. So looking up beneath between the bulb T beams, that aluminum material that you're looking at now is what is known as the stay in place form. So the stay in place form, or the formwork, was not removed after the bridge deck was poured. And in between that concrete structure, that concrete beam, that steel beam that you see that is attached to both bulb T beam, is what is called the brace. So the brace is there to resist against lateral movements and torsional movements that is going to be attributed to the beam when the beam is being loaded. So it is just basically there to keep the beam stable when the beams are loaded due to vehicular loads. So we have here, we have abutment 2 and abutment 1. And what I didn't point out to you when I was doing those bridges in Jamaica, that how do you differentiate what is abutment 1 from abutment 2? It is based on the stationing on the bridge. So if the stationing on the bridge starts from that direction, that abutment is known as abutment 1, and vice versa. Right? So if the stationing was commenced from this end, this abutment will be known as abutment 1, and the abutment on the opposite side will be abutment 2. So as I said, this bridge spans 6 lanes. There are 3 lanes going in opposite direction, and the name of this pavement or this bridge is known as the SR 422, State Route Bridge 422. So what you're looking at now here is the embankment slope, and the embankment slope is protected by what is known as R8. So R8 stones, they range from 24 inches to 42 inches. No, I think this is R7. This is R7. So R7 stones ranges from 18 inches to 32 inches. So that's R7 stones is used to protect the embankment slope from soil erosion. And the same thing on the opposite side. So that is it for the presentation beneath the bridge. So I'm going to take you up on top of the deck to show you what is going on the Bebo Arch Bridge. So this is on top of the Bebo Arch Bridge. So across there, if you can see, that's the second bridge that I was speaking to you about. So you can see the vehicular traffic. So that lanes, we have 2 lanes going in one direction, 2 lanes going in the opposite direction from east to west and from west to east. And that is that pavement, or that bridge, or that road pavement is known as SR 422. That's State Route SR 422. So as you can see now, on top of the Bebo Arch, this is approximately a 4 to 5 feet wide sidewalk, and here we have the guide rail. So this is the guide rail, and at the end there we just passed the boxing gloves. I'm going to show you what the boxing gloves looks like. So there are 2 aspects of guide rail. There are leading end and there are trailing end. So this is a side railing, as you can see, to prevent people from walking on the sidewalk not to fall over. So, and this is what we call the barrier with flare ends. There's a barrier here and there's a barrier over the other side. So this barrier too, and because the barrier was unfilled, we have to put in what is known as a moment slab. So the moment slab is to correct the rotation of the barrier when the vehicle comes towards the edge of the pavement here, and would affect the barrier from toppling over. So that is why the moment slab was put there, because this here, the entire pavement here, is unfilled, is on structural backfill with a slab, with a deck, a concrete reinforced deck, which was placed on top of the structural backfill to form the pavement for the road. So this is it here, and as you can see, There are reflectors. These are reflectors. These are reflectors on the concrete barrier here, right? So let me show you a little bit of the surrounding. So that is, if you can see the sign, Bridgeport Valley Forge. So this is in Norristown, Pennsylvania East Norriton. So that's the area that I lived in. So below there, you can see the pavement there that goes underneath the Bebo Arch Bridge. So as I can remember, that little old house there was a cooling out area for me while I was an inspector on this bridge. I used to, because when it gets to the summer here, it was very, very hot, and that little house there on the veranda, I used to go over there and cool out during the course of the day. So that is it, folks. So I've shown you the different bridges, some of them, and I just want to point out that in this general area there are a lot of bridges, and I work pretty much on all of them. I worked on them while I was a construction inspector for a consulting company, and I work on some of them while I was a civil engineer, still a civil engineer for the Pennsylvania Department of Transportation. So this is what a boxing gloves look like. If you notice, it shapes like a boxing gloves, right? It shapes like a boxing gloves, and that is why we call it a boxing glove. So that is the energy absorption guide rail. So if you're crashing it, the guide rail absorbs most of the energy from the vehicle, and that energy is not transferred to you, so that you can get serious damage as a means of your accident. So the guide rail is energy absorption. So when you impact it, it takes in the vehicle and absorbs the energy, so that that energy does not transfer to you and cause more damage to you. So that is it, folks. So for this video, if you like the video, share the video, and in the event, you can still tell me what you want to see. You know what I mean? I'm just here bringing engineering information to those of you who want to learn, or to inspire young youths who want to go in the engineering profession in Jamaica. All right? So take care, enough respect, and I will catch you in my next video upload. Maximum.